Pharmaceutical Processing, in conjunction with INTERPHEX 2017, presents INTERPHEX Live.
Welcome back. So we're going to be talking about capsules, the go-to dosage form. And we have with us today Jonathan Gilinski from CapsCanada. Jonathan.
Thank you for having me.
Michael.
How you doing?
Associate of mine, engineer par excellence. So what we're going to try to talk about is we're going to revisit the whys and wheres of going to capsules. Fortunately, because I'm old, I have a long memory. So I'll start off by saying there's always been capsules. Anytime you're looking to do a clinical study or a clinical dosage form, the capsules were the route. It was easy to fill, straightforward, dissolution was good. You could put straight active ingredient in it, you had to make a blend. And pretty much that was it. You know, that was the way you looked at it. It was the clinical dosage form of choice. I think things have come a long way. My first question then is going to be, what have we been seeing with the use of capsules? In other words, what we're hearing now is, when we did it, the capsules were part of small-scale human studies. But, we talked a lot about it. It looks like we've tailored it to be small-scale animal work, small-scale human studies, straight active. So, Jonathan, what have you been seeing as far as the use of capsules in the case of, manufacturers, small batches, clinical batches, animal batches? What have you been seeing?
We've seen a lot of interest in the preclinical capsules, smaller size capsules, size 5 capsules. We've also seen a tendency to move towards HPMC cellulose capsules, and new specialty capsules for liquid fill have gotten into the mainstream as well.
So what I'm hearing now is, before, dosing animals was we would try to do it as simply as possible by gavage. What I'm hearing a lot now is small capsule sizes used for dosing animals. You see that's a very common approach.
What happens with the capsules, you're able to accurately dose to the fraction of a milligram. So they become quite prevalent in the preclinical stages. And so because of that uniformity, we've seen tremendous response to it. Again, the liquid fill capsules in this particular case for pets improves absorption of poorly soluble drugs.
Mm-hmm. So I've heard a couple of times that liquid fill. Let's going to put that on the back burner. We're going to be talking about that a little more because, to be honest, when I think capsules, especially hard gelatin capsules, I always think of powder fill.
That's the main conception, but it's interesting to see that you have the ability to do powders, pellets, solubles, and semi-solubles, and the growing tendency towards the liquid.
So it looks like it's become even more of an
all-in-one
entry. Yeah,
it's the best of all worlds. That's why we're seeing the increase in demand of hard capsules. You can do with a hard capsule what you can do with many other delivery forms.
So I think we see, it sounds to me like we've touched on the myriad of uses. I think we could look at all different types of fills. Sounds to me like with just using a capsule, we can avail ourselves of multiple types of dosage forms: sustained release, immediate release, extended release, pulsatile release.
Keep in mind the capsule helps you achieve that, right?
Yeah.
You have capsules also that prolong the release, such as the enteric capsules. So, we can go into several details of each specific type of capsule.
All right, tell you what, why don't we do it this way? One of the things that, the concept I want to put out there to keep in the back of everybody's mind was, customarily you look at standardized timelines, and Mike and I had talked about this a little bit too, and the time to market was actually faster. The development time was actually faster for capsules as opposed to tablets. And a lot of companies, they recognize that, and they have this perception that, we'll do capsules to start, but we'll launch tablets, which imposes a transition that, in certain cases, I don't really get. But in general, the route to market by capsules it's pretty quick. So Mike, you want to just comment on that?
Well, I think that the reason that is true is because it's very easy to formulate within a capsule. When you take a tablet, to properly formulate a tablet, you're looking at trying to balance 10, 11 different ingredients, trying to figure out each one of their different characteristics to make a fully a tablet that will dissolve properly but will also stay together, not be friable. Whereas if I'm going to formulate a capsule, as long as I know what the active ingredient is, I can, for all intensive purposes, just put the active in the capsule. And then I can do whatever else I need in there, and it becomes much easier and quicker to formulate that and get it in its end dosage form than trying to develop a capsule that will meet all the appropriate characteristics and then have to taste mask it and coat it.
Right. You just have to keep in mind one thing, and that is, the drug substance itself has to be amenable to flow. You have to put materials in it, but customarily it's a pretty straight up and down thing.
I just personally love the versatility of the hard capsule. There's so many things you can do with it, and to add to Mike's, you can use the hard capsule to conduct small batch runs, which in some instances and in other dosage forms, it's tough to achieve. So that gives you also an advantage when you're able to sit down and do different batches, store different ratios, specific formulas, and run them within a single single device.
Hey, I got a couple of things along those lines I want to pursue as we get into it. But before we get too much further, let's Jonathan. So, HPMC versus the conventional gelatin capsule. I mean, what drives people's selections on this thing?
So HPMC has gained tremendous popularity, and we've seen an increase in demand. I personally see both nutritional supplement and pharmaceutical industries heading towards that direction for both dietary restrictions as well as overall performance. Now, I keep going back to the versatility. HPMC capsules are more receptive to liquids as well because of their lower moisture content. So it seems as though people don't want animal byproducts and they're switching to HPMC, and they're finding that they can do as much or more with an HPMC capsule and at the same time have the same results in terms of dissolution, for example.
Okay, how about machinability? I mean, if I'm running, just out of curiosity, I'm running certain types of equipment, and I'm going to bring an HPMC capsule online. Is there machinability issues? Are they pretty much easy to deal with?
It depends on your machine, but they perform exactly the same as gelatin. If sometimes little or no adjustment to the machinery is done. In our case, our K-caps, very small losses, so it all turns back into your profits and your finished products. Excellent machinability is what we've seen and what we've noticed with our product.
From the processing side, I mean, have you, with the clients you've dealt with, Michael, have you seen when they change over, or any input on that?
We'll see, as an engineer or a design engineer, typically that the drug product's already been designed. But what I'll say is that I find it much easier to design a capsule product run versus a tablet because, there's typically fewer ingredients, right? And so my batch formulation is smaller. I have fewer unit operations typically. And so my facility's smaller. I use less utilities. And when you're looking at it for your client and what I do for a living, which is to try to give them the best cost facility for the best advantage, is I have smaller footprint, I have fewer utilities, and I'm still getting out the same type of products for them. So there's so much advantage from the engineering side that I really wish that more people would look at that up front when formulating to the advantages of capsules for their company in general.
If I can add, because Mike has some great points, I've noticed pharma companies using high-speed output capacity machines to conduct clinical batches. It ultimately turns into downtime when you can be able to do small batches on different types of machines and use your larger output machines for industrial production.
Right. And that, if you don't mind, is so ultimately where the industry's going is the R&D on continuous manufacturing, right? For that same reason, why produce at a really high rate and then have downtime equipment? And what makes the capsule very advantageous for that is that one of the hardest things to judge or to model correctly is that relaxation time between compression and when I can coat, right? And so now I have to figure out how to create that inline whip, so I'm still calling it continuous before I can get it into a coater. Well, that goes away when I go to a capsule because I'm getting my taste masking, I'm getting my oxygen barrier or light sensitivity barrier off from my capsule, and now all of a sudden I don't have to worry about it. And then also for the continuous, I only have to worry about maybe 4 or 5 inline feeders because they're typically direct blends, whereas if I go continuous for a tablet, I could have multiple inline feeders in unit operation.
What about when you're working with a high potency APIs?
Right.
Your capsule is some sort of acts as a sort of a containment, right?
Exactly.
We've seen that, especially in practice with oncology products, right? Very small dosages, very potent. Your capsule prevents.
Right.
It helps protect the operator, which is key. And sometimes, under the impression, dusting doesn't. You got the dusting with the.
We find
with the tablets, right?
Right. So traditionally, one of the biggest dust generators is the capsule coating or the tablet coating function, right? Because I'm loading the tablets into a perforated pan. I'm starting to spin them. I'm generating dust. Now I have to evacuate all that and put it in a dust collector, and that's all high potent.
And you have to think
Right.
of the operator's safety.
Exactly.
In this case.
So once it's in a capsule and it's polished, I've already got it completely, like the risk of potent containment has been mitigated. My OEL limit goes way up and it becomes much easier to transition.
So I'm actually hearing a couple of things here I think we're going to want to spend a little more time on. I mean, what I'm hearing about is continuous process. I mean, for one thing, the first thing that pops into my head is not usually capsules as the output from a continuous process. I think that's something we're starting to see more when we design processes. And the other aspect is, and I think maybe if you were listening closely, you picked up on, we compare process chains to a coated tablet. The rationale there is, as Mike and I have talked about.
Right.
Why don't you get in?
All right. So
why we make that?
So there was a myth a long time ago that it's cheaper to produce a tablet to a capsule because the output of a tablet machine is much higher, right? And so you have an equivalent capital expenditure, but I'm getting more out of a tablet press. The problem with that rationale is that that's only apples to apples if you're truly comparing a coated tablet, because again, a capsule gives me a taste masked product that I don't have to worry about, and to truly compare it, I need to go to a coated tablet, right? And so when you bring in all the time for the coating, the capital expenditure for the coater, the energy involved in that, it's on a factor of 10 to 20% cheaper from our historical data to produce a capsule than a direct blended coated tablet.
The efficacy is there as well. I mean, some might argue that a capsule is more efficient than a tablet because you're getting the medication at once. Sometimes when you consume a tablet breaks into various different pieces and segments, and it does not dissolve all at once, right? As opposed to having a capsule, which is the solution profile releases 100% in under 45 minutes.
Well, I mean, when you're trying to formulate a tablet, you got to figure out how do I balance all the different material characteristics and get it into something that'll stay together. But then I also have to figure out what I can put in there to absorb water so it breaks apart equally and it dissolves appropriately. Whereas if you stick those same active ingredients and other ingredients into a capsule, a lot of those headaches go away.
One of the things I've found when I have done development work for many, many years, and I found that the best thing to do is always have a process engineer as part of your team. because they ask questions, well, you spend all this time developing the compression physics necessary to make a tablet, Russ, but at the same time, you know, we got to make it fall apart so you get the dissolution. So it's sort of like, you know, you get hit in the head with the Lockman and Lieberman book, you know, bang, like, oh, yeah, we're right. So I'm spending all this time to get this stuff to flow and compress so I get the hardness I want, but I want to make it dissolve quicker. So if you trade that off with a powder fill, that's where this stuff starts to come in. That, you know, just so you get the logic, or non-logic as the case may be, but that's where this is coming from. But one of the things that we also talked about is, while we're on the subject of continuous process, the actual footprint, Mike, when you guys have put in continuous processes, if you looked at one versus the other, the amount of real estate is actually less in the case of a capsule. Did I get that right?
Well, so in a traditional environment, if you go a direct blend to a tablet coat versus a capsule, you save 20 to 25% of your facility footprint because you've divorced yourself from the capsule, the tablet coating, all the formulation area for the coating, and then all of the utility space, AHUs, dust collectors, which there's a lot for that. And so the footprint alone. Now, when you go to capsules again, it's a little bit different, but the same rationale holds true. Is I don't need the tablet coater. I don't need a spot to generate that coating solution. I lose a lot of the mechanical space in the dirty side of that continuous, so that room again gets smaller, but it doesn't fall in the line with that 25% reduction. It's closer to 10, 15, but still there's a reduction in footprint.
So what I'm gathering is you don't have a lab scale type of setup for tablets, where it's a small apparatus and studies can be done, film can be done in a very small amount of space.
No,
with very little footprint.
I'm talking about a 5 to 25 kilo production rate for that. And so when you talk about a coater that'll work for that in a continuous coating environment, again, you have a footprint it's rather large. You have air handlers behind it. You have a large technical spot, right? So with my feeders, I don't have a lot of technical space required. If I'm doing a direct blend, I have very little mechanical space involved required. But when I get to that coating function, all of a sudden I do. Now, if I go, all bets are off if I'm going with a wet granulation, because then I have a fluid bed and that gets exponentially worse. But if we were just trying to compare a coated direct blend tablet to a capsule, because those are the closest equivalent, you'd still save footprint, cost, utilities, and both clean side space and dirty side space from an engineering perspective.
Okay, but arguably, and the reason that is that we bring that up is just so I'm sure you guys are all sitting out there thinking you don't have to wet granulate it. The idea of being roller compaction. You guys should remember the plasticity of the materials that you select have to be such that they will survive 2 compaction events. You know, sometimes it does. I got to tell you, I've only run across one that once you rollered it, you couldn't compress it because you took away all the plasticity, which meant you're only left with elasticity, so it doesn't make a tablet. So what we're trying to do is compare these things directly next to each other. But roller compaction, what does that do to the footprint?
Well, compaction is rather easy to actually fit into a continuous line. It by itself is a unit operation that was designed to continuously be fed. So it fits in well. You don't have a lot of mechanical space behind. It usually has, your continuous line has to get higher in elevation. And so it's not difficult to fit in line into a continuous line.
So Jonathan, what I'm seeing is that, if you want to take your clinical form, which I submit, my rule of thumb is if I see that somebody is selling a capsule, that's usually their clinical service form with a new color. They usually launch with their clinical form. The idea is really to get from the clinic to market as quickly as possible. Where do the problems reside? Scale up, usually when you try to make it faster. But the answer is if you minimize the size and you go to a continuous, you would put everything in your everything is kind of like, given this my span, we kind of put everything in your pocket in that particular case. But there was a piece that Jonathan brought up before and that's the liquid fill. I don't know about the rest of you guys. In my development life, if I was going to do a liquid fill capsule, I thought soft gel. Or worse yet, some magical thixotropic application that I would put on my LZ64. Sorry, that's a whole.
Let's not jump yet into what we're going to get to, but keep in mind the practical fill limit for a capsule is 90% of the body's normal volume. In the event that you have a larger dosage, sometimes the capsule is not your better option. So we have to consider that as well. You need to sit down with either the capsule experts and your formulator and figure out, well, is this formula compatible with a hard capsule, right? I like to use, let's say, fish oil, 1,200 milligrams of fish oil. It's not suitable for a hard capsule. But this particular product that we have here from our client is a lipophilic solution with hydroscopic properties in it, 400 milligrams of ibuprofen in a gelatin capsule with a special polymer, right? Thinner walls aid in the bioavailability of the product as well. So again, you got to be able to understand, is my fill material applicable for a soft gel or is it applicable for a hard capsule? Mainly potent APIs such as this one will do well in a hard capsule.
Okay, so if I go down the normal road and I say, okay, it's inside. Here's a better scenario. Now we all know that most of the new oncology drugs, well, I can't say all of them. The ones I've had on have the solubility of sand. So having said that, I would think that a suspension would probably be a good idea, right? So if that's what I want to do, and I wanted to do something like that, rather than a soft gel, what I'm hearing now is there's an ability to put them in hard gel.
Yeah, on the suspensions, we've seen, again, it goes back to the HPMC, because of the lower moisture content, we've seen an increasing demand for HPMC capsules and use in suspensions.
So
keep in mind that if the API is extremely hydroscopic, it will retain moisture from the shell and it will create brittleness, and that will work. So you need to be able to say, well, either my solution or my suspension, what capsule works best? For suspensions, HPMC works really well because of its lower moisture content.
okay, so in principle, I mean, if you think about it, if you want to assure bioavailability, you want to make sure you get the accurate fill. I mean, one could argue that capsules, probably in early stages, make a lot of sense as a powder form. And what I'm hearing too is that one of the things is you don't have to limit yourself to simply powder fill. A suspension would be just as bioavailable and probably more so.
From a business perspective, also, when you can extend your product's life cycle and patent to reformulate into a liquid capsule.
Right. Let's look at this. So what else is it? Right. We keep talking about early stage, the jump to continuous, the jump to commercial. But let's look at something that I think one of the biggest things we talk about with engineering, again, since I've been working with engineering, is containment. I mean, God forbid, right? I mean, I've seen palaces built to the memorial container. Don't I kind of like diffuse that bomb if I make a liquid?
Greatly. The risk of your low OEL active ingredient now getting out in the air is greatly reduced or mitigated once I get into liquid, right? So if I can get that into a suspension, once it's in liquid, my risk goes down and my operating ability becomes much easier.
You can also fill capsules in a nitrogen-filled environment, which helps with containment as well.
So, getting back to the continuous process, just so we can bring that full circle, the liquid fill, I would think, would make the continuous process dimension even better.
It would become very easy. It would become a formulation exercise right to your hard shell capsule machine. It would become very much like an aseptic filling suite that instead of filling a vial, you're filling a capsule, but without the risks of an aseptic facility or the requirements.
All right. Well, I guess my question would be is, ideally, I remember doing thixotropic fills, and it was a real pain in the backside when we did it. We ran into numerous problems. So why don't we build on that a little bit? If I wanted to get involved in an early stage of liquid fill, John, what options do I have in front of me?
The first thing you want to do is take a look at your formula. So your formulators will work with us and will understand the breakdown of the formula. After we've evaluated the formula, then we will decide what type of capsule is best suited for that formula. Keep in mind that capsules have evolved over the last 6 decades, and there's just a whole array of different capsules for specific liquids. So there's a recipe for each one. That's where you would come work with us in your formulator and decide, well, should I go with an LQ cap, gelatin, special polymer for a hydroscopic API, or should we go with the HPMC or a K cap for a hydrophobic API?
So there's a whole bunch of different options we can play now, right down to controlled release. Is that?
You have the ability not to have the enteric capsules, which would bypass the stomach, goes into the intestine. That obviously gives you a higher bioavailability.
Wow. Okay. All right. So, but let me ask you this question. So, if we wanted to get to the point where we wanted to actually fill capsules with a liquid, what does that usually involve from a process standpoint? How do you guys want to?
We have a benchtop capsule filler. It could get you started right away. And this specific machine that we've developed stores ratio-specific formulas. So with this machine, you can do the small batches of capsules on different formulations. So you'll be able to fill size 5 up to 00 on the same machine. So again, I go back to the point of just the incredible versatility that comes with using a hard capsule versus other forms. Keep in mind, I love capsules, so I'm a bit biased.
I didn't pick that up. So it's a liquid filled. Okay, I got it. So from that standpoint, the footprint would still be the same for a continuous process?
It would probably get much smaller, okay, because now I don't have to worry about the height of the fillers, the loss in weight fillers going to any direct blend. All I have is a formulation area and then some piping up to whatever your filling or dosing reservoir would be, and so it would be a small room.
So, okay, so how do you go from small to large? Are these things tunable, or the output, or?
Your entire validation doesn't change. You take the process from a benchtop and you just transfer it to a higher output machine, and nothing is going to change. So your scale up is foolproof.
I got you. So what do you do? Just clone the machines?
You go into a higher output machine with your formula already in place, and put that and just increase the output capacity. So you can easily scale from benchtop to a larger machine without any changes whatsoever.
It would seem to me that we gotta, I think something like this is something we have to educate industry about, that this happens to be another option we can follow.
Absolutely, that's the reason we are here at INTERPHEX, is to educate on how you can start from lab scale up to commercial scale without the minimum changes to your entire process.
Right.
It's still using the capsule, right? So you're not changing your dosage form.
One of the other things that we talked about was, this transfer, the tech transfer, or the introduction of the process. I mean, that's still part of it. What I was thinking that one of the other things that we always run into is, at least in my is that the clinical service forms that we use were always white, right? And unless you wanted to launch with a white capsule, you had to go through a reformulation. So what I mean,
Yeah, again, that goes back to the versatility. What we've developed is the FM caps, fast to market capsule, which is an all dye concept, meaning we've incorporated all the dyes into the capsule along with the printing. And it's a process of reformulation by dye elimination. So we'll conduct the studies with the capsule with all the colorants. And then once you decide what your final market image is, you simply eliminate. You do not have to now go back and conduct the same studies with whatever color you chose. That saves up to 18 months, 6 months. Time is money, so you do save on that specific concept. So that particular capsule gives you that ability as well.
and this could be done with HPMC capsules, gel capsules.
We're offering it with both HPMC and with gelatin. I do bet on the HPMC being more successful because of the tendencies of the industry shifting their consumer patterns into the HPMC capsule.
Well, I know from my old work, that's less stability for sure. Invariably, the marketing guy always wants, purple with blue spots or something, and that always causes a problem. All right. I think one of the things we need to understand. I think one of the other things we need to understand too is what is the standard process train on these? Is there anything else downstream if you're going to do a liquid fill? Is there anything downstream, weight check, anything else that we need to customarily do?
Yes, when you are filling liquids, you have to consider whether you're filling suspensions or solutions, because in certain instances, if it's a solution, you might have issues of leakage. So you're going to want to consider banding and sealing your capsule, and that has various benefits to it. You seal it, you band it, you lock it, make sure it prevents the capsules from leaking, prevents the capsules from getting oxygen in them, acts as tamper resistant as well. So you want to consider banding. It's highly recommended when filling liquids. We've seen suspensions that are hydrophobic on our HPMC capsules that have gone a year, 2 years without banding and have not leaked. So again, you need to sit down with us and we need to study your formula and we will decide whether or not we should recommend banding. Although I tend to band it. The other thing that we highly recommend is blistering. If you blister seal your liquid capsules, and if one leaks, it doesn't contaminate the other. So it's highly recommended that if you're filling liquids, you also blister pack them.
So, is that customarily a coating process?
The banding process is a sealing process. So if it's a gelatin capsule, you formulate your gelatin, and you just simply pass it through the machine in between the cap and the body, sealing the cap and the body together. Right? That would be a gelatin formulation. If you have HPMC or K-caps capsule, you're going to use your HPMC or cellulose formulation that will create the banding that you see here in this particular case, red. Obviously, this is red, some can be blue, you can play with the colors. If it's an enteric capsule, then you have your enteric banding kits specifically for that. So I wouldn't call it a coating, I would call it more of a sealing banding technology. Very common, very prevalent in the industry.
What's your take on that?
Well, I mean, it's obviously another unit operation or another step with a brake. So again, it becomes more tricky when you go into a continuous operation to figure out what the throughput of that banding operation is and trying to mirror those throughputs. And again, so the liquid operation is something new to me in these type of capsules. So you'll have to forgive me, not having some historical data on that, but to me it would be the equivalent of having to keep my whip until I took it to a coater if you're going for the equivalency of a tablet.
Now,
You got that right.
Right, but if you want to scale from a laptop to a high output, machines have the ability to fill liquid and band within the same machine. So you're actually, it's one process throughout.
Oh, so you'll fill
So
end
it
band in the
fills and
same
adds
in the same in series.
Integral
Oh,
in the process.
okay.
I want to make, I'm glad we clarified.
That's how our pharma customer does it.
Okay, so
They have a machine that fills the liquid and bands it automatically.
does it affect your overall throughput? Like if my typical capsule machine could do 100,000 per hour, but if I have to both fill it and band it, does it reduce my capacity?
It's within. You're still filling at the same speed.
Okay.
You'll have a slower output because you do have to band, so that's going to decrease, but it's not significant.
Okay.
So we got, sounds to me like there's a couple of advantages. Let me make sure I got the notes right here.
We haven't touched on printing, colors, flavors. I mean,
I
can spend all night here talking about capsules.
Yeah, I think we'd have.
I have dinner
We
reservations.
probably need to take a break.
No, and buy beer, one or the other. But what I'm seeing is, it's the reduction in stability time. If all you want to do is just use capsules with an all color approach, that option is still open. It sounds to me like the approach to do early clinical development using liquid fills is made a lot more simpler. Quite honestly, I think it's to our advantage. I couldn't tell you how many times I've tried to do liquid fills, and it was to the point where we were looking at soft gelatin as an in-house technology.
I invite you to visit the CapsCanada booth so that we can educate you further if anybody is interested, because we have a lot more to offer in this subject matter.
Okay, yeah, especially if we got to buy everybody dinner, one or the other. So with that, I want to thank you, gentlemen, for the time.